Welcome back, and today we're starting our series on quadratic equations. So today we're just going to have a look at an introduction, see what it's all about, and do a couple of basic examples. So first of all, let's think about what quadratic equations and we've just finished linear equations are all about. So we learned that with linear equations, they were linked to the drawing of a straight line on a Cartesian plane. So let's take any arbitrary straight line and put it on this Cartesian plane, and we'll see that that straight line intersects with the x-axis at one point. There are straight lines that don't intersect at all, but in most cases we're dealing with a straight line that intersects at one point. And if you remember, when we were doing linear equations, we got one solution for x. So quadratic equations, where we've got ax squared plus bx plus c being our general form, that is linked to the drawing of a parabola graph. And we get many different types of parabola graphs, which we'll go into at some future time. But if we just look at one example of a parabola graph, let's say for instance this, we'll see that that graph cuts the x-axis at 2 points. Again, there are parabola graphs that won't cut the axis at all, or will cut the axis at 1 point, but we'll get onto that later on. But in most cases, your parabola is going to have two x-intercepts, and that's why in quadratic equations, we're going to have two solutions to x. So let's look at the first one. The first one's been presented to us in the ideal format that we need to have it in. Because contrary to what we did in linear equations, where we tried to get all the x's on the one side and the numbers on the other side, when you're dealing with a quadratic equation, you're going to put everything on the one side, and the other side will be equal to 0. So how do I recognize whether I'm dealing with a linear or a quadratic equation? And that's very important to know how to start off. Well, all our linear equations only had x to the power of 1. And here we've got x squared. So as soon as you've got an x squared term, you know that you're dealing with a quadratic equation. So if you look at the left-hand side now, we've got our three terms in descending powers of x, and we've learned how to factorize that trinomial into two brackets. So let's do that. I'm going to do the cross method. I'm going to actually write it down. A lot of you will work this out in your head at this stage, but for those who are still needing this, let's do it. And if you've forgotten this method, go back to the series on factorization, and specifically factorization of trinomials, and you'll see all the four scenarios that can occur here. So because this is x squared, it means 1x squared. So I'm saying 1 times 1. 14 I have to factorize, and the simplest way to factorize 14 is 7 times 2. I could also say 14 times 1, but I think you can see that's not going to work. Then I multiply down the arms. So 1 times 2 is 2, 7 times 1 is 7. And then I ask myself, can those two numbers, through addition or subtraction, give me 5? Yes, 7 minus 2 can give me 5. And that's minus sign is showing me that I do need to have a subtraction situation here. So finally, to get what my brackets are going to be, I read across. So I'm going to have 1x and 7. In my other bracket, I'm going to have 1x and 2. And then remember, the rule is, if that sign is negative, the signs in the brackets are going to be different, and the biggest one is going to be that sign. So I've got negative 7x, negative 7, and plus 2 on this side. So what I'm saying now is I've got something times something equals 0. Well, remember, with our properties with 0, one of the factors has to be 0 in order to get an answer of 0. So in other words, either x minus 7 is equal to 0, or the other bracket, x plus 2, is equal to 0. One or both of them have to be equal to 0. So what I've done now is I've ended up, from my quadratic equation, I've ended up getting two linear equations, both of which I'm now going to solve. So in this case, x would be equal to 7, and in this case x would be equal to -2. And that is telling me that if this was drawing a parabola graph, then that graph, which has that shape, or it can also be that way around, is going to cut the x-axis at -2 and 7. So let's look at another example where it's not quite set out as you want to have it set out right at the beginning. So we've got 3x squared minus 2 equals 5x. So first thing you ask yourself is it linear or quadratic? Well, it has an x squared term, so it's quadratic. What do I have to do if it's quadratic? I have to take all the terms to the one side and let the other side be equal to 0. And then also remember to make sure that you put your terms in descending powers of x like they were there. So my 3x squared term is going to be the first one. Then I need my x term next. So I'm going to bring this across as minus 5x. And then that term is staying on the same side as where it is, so it's going to keep its sign, equals 0. So all I've done is I've manipulated that into the correct form of ax squared plus bx plus c equals 0. And now I need to go ahead and factorize my trinomial. So this one's a little bit more involved because I've got a coefficient greater than 1. So if I look on my cross, I need factors of 3. My only option is 3 times 1. Then I need factors of 2. So I could say 1 times 2 or 2 times 1. I'm sure you're noticing that this is going to be the better way of writing it. And if you get it the wrong way around, then you simply have to swap them and see what will work. But let's check. 3 times 2 is 6. 1 times 1 is 1. Can 6 and 1 give me 5? Yes, they can through subtraction, and that is telling me that it is supposed to be subtraction. So finally I read across to see what my two brackets are going to be. And my first bracket is going to be 3x and 1. Notice I put my signs in afterwards because then I'm not going to make a mistake. 1x and 2 equals 0. Keep remembering to put your equal 0. Now, that is telling me that the signs in the brackets are different, and the biggest one is negative. But now that I've got a coefficient here, I need to actually say the biggest combination is negative. So I've got outers giving me 6, and I've got inners giving me 1. So the bigger combination is the outers, so that's going to get the negative, and the other one gets the positive. So that times that equals 0, which means that either the 1 factor must be equal to 0 or the other factor must be equal to 0. So you're going to get to the point where you actually just go from here to the answer. But just seeing as it's an introductory video, I'm going to just go through the details. So remember what I said, we've now converted a quadratic equation into two linear equations. Again, these are two linear equations. So keeping the x on one side and taking the constant to the other side. And then I don't want 3x, I want x, so I'm dividing by 3, dividing by 3. So therefore, x is equal to -1/3. And in this case, very easy, isolate x on the one side and x will be equal to 2. So there are my two intercepts on the x-axis, my two solutions for x. Right, that was just the introductory episode. We're going to be going into a lot more detail, working with brackets, working with denominators, working with restrictions. So if you want to make sure that you see every single quadratic equation episode, please click that subscribe button.